This tutorial will be showing us how to perform independent t-test using SPSS. I remain Adejumo Oluwasegun. When do we consider to use independent t-test analysis? As you know, this is also known as two-sample t-test. This two-sample t-test is preferred if the two groups of interest are from different samples. So it implies that what the two we want to compare if two groups are significantly different from one another. And it's important to know that these two groups must be independent of each other. So let's consider comparing the anxiety level of students based on their test performances. That means those that pass, anxiety level of those that pass against and there's anxiety level of those that did not pass. So we're going to consider our the same data we use for our one sample t-test. We're going to consider that as well. And let's see. We want to compare this, the students, the anxiety level of students. We have variables data on anxiety level of students before the test, and we have the category of people that pass and did not pass. So we need these two. We need these two. So you can see that they are independent of each other. And within the group too, within the the people that pass and did not pass, they are independent of each other. So that's why we call it independent t-test. So remember, this will be imported. We've imported this to the SPSS software, and you can see variable 7 and variable 8 and variable 9. Variable 7 and variable 7, 8 and variable 9. You see? So it's important for us to remember our pass variable is categorical in nature, so it's nominal. So it's important for what group it will label it as. 1 is for those that did not pass the test, did not pass. So we call it did not pass. And we had, and 2 we say are those that pass the test. So let's do this. So this is done. We'll go to analyze. We'll look for compare means, and we'll look for independent sample t-test. So this is what we want. We'll click on it. You can see I've already performed this earlier. So what we need to do is that what would move the observation that is continuous will come here, and the one that is categorized will move here. Remember, it's important for you to define your groups, and the definition of group is 1 and 2. Okay, and we'll have the option. You see, also ascertain that what is at 5% level of significance. So we'll okay this. So let's see the result. So here's the result. You see there's group statistics now. This is a group statistics. But did not pass. You can see the mean of the anxiety is 50.7, which is higher than people that pass. You see, students that pass is 49.7. So we want to check the difference between this. So the difference between these two groups is what? Is 1.3471. You can see 1.34. 1.34. So we want to check if this observed difference, mean difference, is it significant or not? So that's what you have here. Analysis of this test here. You can see the p-value here returns at what? Is statistically significant. So it means that what? the anxiety level of students that did not pass is significantly higher than students that pass. So let's go back to our slide to for further explanation of how it went. So remember our test, our hypothesis is what? There is no significant difference between the anxiety level of students who pass and did not pass, and why uh, the alternative hypothesis is just the opposite of the null hypothesis. And from our test statistics, we could see that what the p-value at the test of inequalities here, sorry, the test of equality of mean, the test of equality of mean shows that what, when you look at the test of equality of mean, look at it there, it shows that what, that we reject the H naught in favor of what, H1, that what, the mean of that means the anxiety level of students that did not pass is quite higher than students that pass. So we conclude that what, thus the anxiety level of students that did not pass is significantly higher than the anxiety level of students that pass. I hope you find this interesting. Thank you for your attention.